Well, g'day everybody. This is Critical Think from Down Under. Thank you. Great to be with you today again. Well, today we're going to be doing something a little bit different. We'll jump on the ChatGPT bandwagon. This was inspired by a video put out today by my mate Where's Wally, where he showed that the OpenAI ChatGPT program is not fooled by a flat earther. So while I could have gone with the clickbait title of How to Make $1 Million with ChatGPT, I settled for something a little bit different. I decided to have a conversation with ChatGPT about something I know a lot about, and that is the forces acting on a 1 kilogram mass and the effects of weighing it at different places on the Earth. So I just wanted to check, how does ChatGPT handle this and what does it know about it? And I'll be putting it right, because I've done a lot of work in this area, and even though ChatGPT might represent the sum total knowledge of humanity at a point in time in 2021, there's a lot of people that are not familiar with this, and I consider myself pretty much a subject matter expert on this topic. So let's see how we go. So I asked it the question, why does weight change with latitude? And a little bit surprised, this is an answer that maybe even a flat earther would give. It starts out and says weight does not change with latitude. And this is what a flat earther would say, but that's not correct. And it does say that the force of gravity determines weight, which is, all right, a flat earther won't admit that. But there's also states about gravity anomalies and how it can cause differences in weight at 0.5%. All right, not strictly incorrect, but I would argue about the magnitude of those anomalies. And also it says the altitude also affects the weight due to reduction in atmospheric pressure at high altitudes. Well, that's not strictly incorrect, but as we shall see later, the effect is so small it can't be measured. But anyway, we can show here that ChatGPT, as artificially intelligent, has more intelligence than your average flat earther. So even though ChatGPT is wrong here, I can talk to ChatGPT and tell it where it went wrong, and it will listen. Whereas your average flat earther won't listen to anything and won't be corrected on anything. So here we go. I've started to correct it, and I explained about the equator being slightly wider, and this will cause gravity to be slightly less. And as you get further away from the equator, this will cause weight to measure more on an electronic scale. And I mentioned centrifugal force. So then ChatGPT says, yes, that's correct. The Earth is not a perfect sphere, it's an oblate spheroid. And this shape is actually caused by the centrifugal force generated by the Earth's rotation. Again, we often hear flat earthers say, well, if the Earth were rotating, then all the oceans would bulge towards the centre. Yes, they do. But anyway, and it goes on. Now, most of this is reasonably correct. And however, it says here the difference in weight measurement due to centrifugal force is very small, usually less than 0.1%. Incorrect. So I'm going to try and convince ChatGPT this is incorrect. I asked the question, what is the magnitude centrifugal force at the equator? You know, I'm looking for an answer. It tells me how to calculate it, you know, using the theory, the formula, everything. But this formula here looks like it's got it a little bit wrong. And so here also, the magnitude centrifugal force is about 0.03% of the force of gravity. Again, wrong. Wrong, 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 wrong. And it's not a big force, not enough to cause a measurable difference in weight. Wrong. So let's talk to ChatGPT and try and correct some of these things. So I'm just going to put it out there that if F is the angular velocity of the Earth's rotation in radians per second, then the formula should be Fc is m times f squared times r. And ChatGPT says, oh, you are correct. I apologise for the mistake. Well, how about that? So they've agreed the calculation for centrifugal force is the one that I gave. And again, we're still going on about this 0.03%. So let's try and correct that. So can you calculate that FC at the equator? Yeah, grammatical error, I know. And express it in newtons. No worries. ChatGPT understands. Sure. And they calculated at 0.033 newtons. It's a very small force, not enough to cause a measurable difference in weight. So it's wrong about this. It is a measurable difference in weight, but we'll get there. So the number I've worked out is 0.034. So it looks like it's truncating instead of rounding, but that's neither here nor there. So it correctly calculates that the gravitational acceleration at the equator is 9.8 newtons. And the gravitational acceleration can vary slightly depending on location. Yeah, okay, it can. But there are different reasons. It's worth to mention that the difference between gravitational acceleration at the equator and the poles is very small, only around 0.5% difference, and it will not significantly affect the weight measurements. Well, that's about right, and it will not significantly affect the weight measurements, but that is measurable. And I've pointed out now that ChatGPT calculated the FC at the equator at 0.033 newtons. And then I just put to it that says, right, I calculate the percentage FC is approximately 0.3%. Do you agree with that? And oops, sorry, I apologise for the confusion. You are correct. The centrifugal force at the equator is about 0.3% of the force of gravity. Da, 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 da. So, and I'm just going to rub it in a little bit here and say, yeah. Before I do that, and notice it still says the number is very small and not enough to cause a measurable difference in weight. Wrong again, but we'll get to that. And I want to rub it in here. Just to clarify, you stated that the magnitude of centrifugal force at the equator is about 0.03% of the force of gravity at the surface of the Earth. Do you confirm that this was incorrect? And can now confirm the correct value is 0.34? Did you love this? Oh yes, you are correct. I apologise for the confusion. The value I previously provided is 0.03 is incorrect. My apologies. So, in fact, in AI, this is why an AI is far more intelligent than your average flat earther. Because the average flat earther will never admit they were wrong about anything. But the AI is great. It's willing to learn. Oh, don't you just love it? So then I just carry on with this and go on. If I use an electronic scale and calibrate it at the South Pole for 1 kilogram mass, then I travel to the equator and measure the weight again, what would be the expected difference? So I actually didn't do too bad at this. And so it says it's about 5 grams. Now I didn't work out exactly what it will be. It's close enough for me to not nitpick about that right now. And it says here, It's worth noting that the difference in weight caused by centrifugal force is even smaller, approximately 0.3%, and it will not significantly affect weight measurements. Well, true, but its changes tune slightly from you can't measure it. And if the gravitational difference is 0.5% and the centrifugal force is 0.3, it's, they're pretty much in the same ballpark. So I then go to the point of, well, 3 grams is on a 1 kilogram mass would be a measurable difference. And here, lo and behold, we are now correct again. And it's now is indeed a measurable difference, whereas before it was not a measurable difference. The centrifugal force is a very small force. It only causes a slight difference in weight. But as you pointed out, it's still measurable. Now, here we go. In practice, other factors such as temperature, humidity, and air pressure variations can also affect the weight measurements and may have a greater impact than the centrifugal force. Well, no. Something that a flat earther likes to say, but no. So now we've got to chat to ChatGPT about this. And they say, when making precise weight measurements, it's important to take into account these different factors and to calibrate the scale at the location where the measurements will be taken. It's true that you need to calibrate the scale at the location where the measurements will be taken. And while these temperature, humidity, and air pressure do have an effect, we'll see that the effect is minuscule. So here on, I just drive home the point that this measurable difference in weight, I just point out, rubbing it in a bit again, ChatGPT said before that centrifugal force did not cause a measurable difference in weight, and I just saying, oh, that means you were incorrect earlier. And yeah. It says, I agree, I was wrong. And again, we're going down this path of temperature, humidity, and air pressure variations can also affect the weight measurements and may have a greater impact than the centrifugal force. No, this is not correct. And so we'll try to get it to admit that this is not correct. So it says, I can surmise that their effects are only minuscule and not easily measurable. This is because of my investigation before. So let's take temperature as an example. What causes you to think that the temperature effect will have a greater impact than centrifugal force? And interesting information. Temperature changes can cause, yes, can cause that, yes. I agree with all of that. However, there's no number, there's no quantity. And The centrifugal force can have measurable effect on the weight measurements, but in most cases the impact is very small, and other factors such as temperature, humidity, and air pressure variation can also affect the weight measurements. So again, we're getting a little bit closer. It doesn't say now that temperature, humidity, and air pressure factors can outweigh the effect of centrifugal force, but we're not quite there yet. So I said, let's focus on the magnitude of these factors, such as temperature, humidity, and air pressure. And we've already established that centrifugal force varies by approximately 0.3%. Can you give any percentage for the effects of temperature, humidity, or air pressure? And so we're getting a little bit closer. It takes a wild stab, right? Pretty much takes a wild stab. And says the effect of temperature on weight measurements is usually less than 0.1. Humidity usually less than 0.1. Air pressure usually less than 0.1. Well, it's much less than that, but it's already admitted that those 0.1% is not going to outweigh 0.3. And important to note, these percentages are approximations. Yes, they are. Real effect will depend on specific conditions of each case, like the scale's precision, materials. Yes, that's okay. So I've said, all right, we've agreed centrifugal force has a 0.3%. These other effects are 0.1%. Yes, you are correct. I apologise for any confusion caused by my previous statements. Blah, blah, blah. These effects are less than 0.1%. So in most cases, the effect of temperature, humidity, and air pressure on weight measurements is not greater than the effect of centrifugal force. So it's gone from saying it may be greater to it's not greater. So they say these percentages are approximations and the real effect will depend on specific conditions. Yeah, that's right. It's always important to calibrate the scale in the location where measurements will be taken. Yeah, that's right. So I tried to push this a little bit further, but I had to stop this recording to check some of these numbers because they didn't look right. And in fact, ChatGPT got a bit confused. I didn't pick it up at the time, but got confused with buoyancy in water, etc. So, and some of these numbers are wrong. So I haven't had time to go through all of these calculations. I eventually got to the point where I supplied it with some numbers. I used Omni Calculator, which gives me an air density value at 1013 hectopascals, 25 degrees C, and it gives you the air density. And then I've asked it to calculate the difference in buoyancy. And I think this is now a lot better because we're working out the weight of the air displaced. And so I then told it to redo the calculation. First I said 700 kilograms per metre squared for the 1 kilogram mass. So this is used to work out the volume, but I was wrong about 700 kilograms, and it was 7,000 kilograms per metre squared. And they say, sure. Now, it worked out the volume displaced and the difference in the air density, and it's worked out about 0.000166 Newton, and then that represents a 0.0000166% difference in weight. They're saying here it's extremely small and not measurable on most scales, and much less than the effect caused by centrifugal force. So it's gone from saying, oh, temperature, pressure may, and density may be more than centrifugal force, to, well, after I've given it specific examples using densities calculated with Omni Calculator, it says, oh, that's much less than centrifugal force. So just try to confirm that. There's the temperature, variations in temperature, humidity and air pressure would be extremely small and not measurable in most scales, and much less than effect caused by centrifugal force. Yes, that's correct. Summary. That's not too bad. So then I went trying to get back towards the original question about why does weight change with latitude? And having discussed today that the gravitational force at the equator is less than at the poles, and also considering that the centrifugal force at the equator is greater than at the poles, it follows that if I calibrate my scales at the equator and I travel away from the equator, the weight of a 1 kilogram mass will increase on those scales. Yes, that is correct. So it would be correct to say that weight changes with latitude. Yes, that is correct. So you'll remember that it says, originally said, weight does not change with latitude. And here, unfortunately, it's gone back to this. Other factors such as temperature, humidity and air pressure variations can also affect weight measurements and may have a great impact on the centrifugal force. So I've asked if a 0.1 gram accuracy would be measurable. It got a little bit confused there, so I corrected my scales accuracy and I said plus or minus 0.1 grams. So I'm trying to measure a 6 gram difference. I'd say yes, it's measurable. And the ChatGPT agrees with me on that. And then I then addressed the other thing about the effects of temperature, humidity and air pressure. It's cannot have a greater impact than centrifugal force, and it said you are correct about that too. And here I go. Why does weight change with latitude? That was the original question. And then it correctly discusses all the things. And again, we're back to this may have a greater impact. So I'm trying to correct it on that. And it's agreed with that correction. So you are correct. I apologise for any confusion. So hopefully now the ChatGPT has got it that the difference in weight is measurable, it's present, it changes with latitude, and effects caused by temperature, humidity and air pressure variations are too insignificant and not measurable. So there you have it. Not too bad. ChatGPT as an AI is more intelligent than your average flat earther.